Okay, so before we get started with the lecture today, I wanted to talk a little bit about grades and grading, since there seem to be some people who are very nervous. So what I have displayed here is the mean and median for each of the 4 GSIs on the 3 assignments that we've had so far, problem set number 1, number 2, and the first exam. The first number in each column is the mean score of those people who completed that. The second number is the median. So you all know about means and medians, I'm sure. The final column, which says weighted average, is just that. It's the weighted average of these 3 components as if this was the end of the semester, which of course it's not. So, but assuming that these were the only 3 assignments we would have, those would be the weighted average grades that we would see for each of the discussion sections. Now, one of the things that you will notice is that there are some variations in grades, not only for individual assignments, but also across the weighted averages and across all the assignments. There are variations in the averages or the medians and the means between the GSIs. Not to worry. How hard or how easy your GSI grades compared to another GSI is not relevant for the final score that you will get at the end of the semester. So I operate on a number of hypotheses here in terms of grading. One is that the GSIs have about 50 or 60 students each, and that 50 or 60 is a large number, and so broadly speaking, the talent and therefore the grades will be somewhat normally distributed within each GSI section, 2 sections, right? So at the end of the semester, once we do have all the grades in, all 6 problem sets, counting only the top 5 and all 3 exams, the individual letter grades and where the breaks are determined by GSI, not for the entire class. Generally speaking, the distribution of grades, that is, what percentage get A's, what percentage get B's, what percentage get C's, hopefully 0% get D's or F's, will be broadly similar between discussion sections. So in terms of your individual grade at this point, what you want to be concerned about is how do you compare with the median in your discussion sections, your GSI's 2 discussion sections. So the median is generally about a B+, sometimes a low B+. So the higher above your discussion section's median that you are, then the higher your letter grade is going to be. So you'll notice, again, that we have very different medians. We've got quite a range from 83 to almost 92, but that doesn't mean that the people who are at 83 are going to get a significantly lower grade than the people who are in 92 in the other discussion section. In fact, they're likely to get the same letter grade, broadly speaking. Okay? So any questions here? I know grading is always a major concern for you. I'm sorry, you lost me somewhere. How is it possible that? I'm not sure, but just a couple of things to keep in mind. How was that? Why that's possible? I don't know. Yeah. So one possible reason is that there are different numbers of people who took problem set 1, problem set 2 in the exam, so that would be one source of deviation there. But that's a good observation. I don't know. Anything else? So take these numbers as approximately correct. Okay. Okay. So let's go to here. Into here. Okay, now, so one of the things that we haven't talked so much about in the last week or week and a half since our exam has been the distribution of income. We've chatted a little bit about it and how it's much less severe with intra-industry trade than it is with inter-industry trade. But if you remember back to our models of comparative advantage, when we had the Heckscher-Ohlin model as well as the standard trade model, we saw that there were some very, very significant distribution of income effects from opening up to international trade or moving towards increased trade liberalization. The impact of these changes in the distribution of income often leads to the parties that are being hurt or disadvantaged by international trade appealing to their governments for some sort of trade protection under a variety of different justifications, which we'll talk about in much more detail next week. So this week, what we want to think about is, if we're going to have trade protection, what is it likely to look like? And how can we assess or make sense of the impacts of these trade protections? So we want to talk eventually about tariffs today. And then on Thursday, we're going to talk about import quotas and something known as voluntary export restraints, one of my favorite topics. Now, first, we have to remember that trade policy analysis or trade policies, the impacts that they're going to have, both on prices as well as on economic welfare, are going to depend upon the size of the country. Are we talking about large countries or small countries? Now, remember, when we talk about country size, we're talking about how large is the country's imports or exports in relationship to the total world trade in that particular good or service. Now, small countries are, by definition, considered small because they have a really small share of the world trade market. And their domestic trade policies will not affect the world price. Okay? Large countries, just the opposite. Large countries are big enough to affect not only the domestic price, but also the world price. So when we think about trade policies over the next several weeks, we'll need to keep this distinction in mind between small countries and large countries to see what the differential effects are and what the implications of that might be. So one of the things that we're going to want to do is to measure the economic welfare effects, not just the price effects, but also the economic welfare effects. And the way that we do this now with a more of an industry model as opposed to the general equilibrium trade models we were using earlier is to think about who gets harmed and who gets benefited by any particular trade policy. So we'll be looking at things like changes in consumer surplus, changes in producer surplus, and does the government collect any revenue And if so, who is it distributed to? Or does the government pay out some of its revenue? And who is it distributed to? So we want to see what happens to the flow of money. And again, who's helped and who's harmed by these various trade policies. So if we thought about a generalized market, we would see that in this particular market, we would be in equilibrium at a price of P naught and a quantity of Q naught. We've got our general supply curve and our demand curve. Now, in this analysis, it's important to remember that a demand curve is can be also thought of as a willingness to pay. So when we think about demand, what we're really saying is what this shows us is at various different prices how much consumers are willing to pay in terms of the quantity that they want. Or for a given quantity, how much consumers are willing to pay in order to buy that amount. On the other hand, a supply curve can be thought of as a willingness to produce. So at every price level, what the supply curve tells us is how much business firms are willing to produce of this particular good. So we need to keep those concepts in the back of our mind. Now, we want to think about consumer surplus, and I know most of you already know this, but just to bring everybody to the same level. Consumer surplus is essentially the difference between what we actually pay and what we were willing to pay as consumers. So that gives us a measure of the surplus that we gain as consumers. So here's a demand curve, or a willingness to pay curve, and here's a, let's just suppose that we're at P naught and Q naught. Then the consumer surplus, in this case, would be this region in here. So that triangle then gives us our consumer surplus. Notice, all consumers only have to pay price P naught. Some consumers were willing to pay a higher price than that. And that's so the value of what they were willing to pay, but didn't actually have to pay, is what we refer to as their surplus. Okay. Now, one other thing that we can see is that if the equilibrium price were to fall, say to P1, notice we can now see that consumer surplus will increase by that amount bracketed by the blue lines. So lower prices increases the amount of consumer surplus that we have. Total consumer surplus is the blue area plus the red area, right? It's the entire region above the actual price, but below the demand curve. Lower prices increase consumer surplus, and I'm sure you can figure out that higher prices would reduce consumer surplus. We can make a similar argument or discussion about producer surplus. How much do producers gain? So again, it's the difference between actual prices and what they are willing to receive for their production, the minimum amount that they would have been willing to receive. So here, we can see that our producer surplus would be, here's our actual price at P naught. Some firms were willing to supply some output at lower prices. So in this case, producer surplus is given by this red triangular area. Again, it's the region below the actual price, but above the supply curve. Now for a producer, a higher price would also increase the quantity supplied, say to Q1, but it would also increase the amount of producer's surplus that's being generated. The increase in producer surplus would be given by the blue area, and the total amount of producer surplus would be the red triangle plus the blue region, the area below the actual price but above the supply curve. Okay? So this gives us a way then to think about how a government policy action, which will change prices, can be measured in terms of how consumers are better or worse off, as well as how producers are better or worse off. So let's think about where we're going to go here. We're going to take an example where we have two countries, the United States and China. And we're going to have one homogeneous good, tires. Yeah, these are the tires that go on automobiles. So this is a real case, happened last year, end of last year. We're going to assume that the market for tires is perfectly competitive, and that initially we're in free trade, with China having a comparative advantage in tires. We'll assume no transportation costs, just to keep it simple. And what we're going to do is a partial equilibrium analysis. So remember, we talked about partial equilibrium analysis before. With that, what we're basically assuming is this industry is small enough that we don't have to worry about what's happening to any other industries. So if we're expanding, we don't have to worry about where the resources are coming from. If we're contracting, we don't have to worry about where the resources that we're releasing are going to either. Okay? So here, we can think about our autarky situations. And what we should see, and in fact do see, is that the autarky price in the US should be much higher than the autarky price in China. Why do we know that? I mean, other than I drew it that way. China has a comparative advantage, right? So this is where we begin in autarky. Now, clearly, once international trade opens, we already know what's going to happen, right? Chinese tire producers are going to say, wow, we can sell this stuff a lot cheaper in the U.S., so let's send some of our output to the United States. As they sell some of their output to the United States, there's less available domestically, so now the price begins to rise. As the price begins to rise in China, two things happen, right? A higher price reduces the Chinese quantity demanded, and it increases the Chinese quantity supplied. In the United States, just the opposite is happening. As tires are being imported into the United States, Now what we're finding is that there's more competitive pressures in the U.S. tire market. With that extra supply coming into the market, now prices will begin to decline in the U.S. Lower prices has two effects. It will increase the quantity demanded for tires in the United States, but it will reduce the quantity supplied of tires from domestic U.S. production. So we know once that we begin into trade, the autarky price in the U.S. is going to fall and the autarky price in China is going to rise. We also know that China will export tires and the U.S. will import tires. So now what we want to do is try and figure out what the world equilibrium price will be and what the volume of trade will be. Now, one way to do that is to introduce two new curves, right? As if we didn't have enough already. Let's think about the U.S.'s import demand curve. In other words, we want to think about how much imports are we demanding in the United States. So at various different prices, what we would see is there would be some domestic demand for tires in total. There would also be a domestic supply of tires, which may or may not match. In fact, at autarky, they match. But if we had any lower price, they won't. That demand will have to be filled by imports. So we want to calculate that import demand curve. China has exactly the opposite problem, opportunity. There are no problems, only opportunities and challenges. So China needs to figure out at various prices how much it will export. So if we take a closer look at the U.S., we have our domestic market and our autarky price. Given our autarky price, there's no reason to, or any price above this, we would not be importing any tires at all, right? So there are no imports here. So if we were to calculate an import demand curve, we would have zero imports at this autarky price. Now, let's assume instead that this were the price, call it P1. So notice that at price P1, the quantity demanded would be D1, and the domestic quantity supplied would be S1. This difference, of course, would have to be our imports, M1. So now what we know is that if we had price P1 over here, we would have M1 imports. So that gives us a second point on our import demand curve. So just vary the price, figure out what the imports are, and then plot that price in volume of imports. And so this becomes our import demand curve. Notice that the import demand curve is simply derived from our domestic demand and supply curves. And in fact, it's just the horizontal difference between the supply and demand curves at each price. So if we're going to fill our quantity demanded at each price, we can figure out how much is going to be supplied domestically. The rest of it has to be imports. So that's where our import demand curve comes from. For China, the process is exactly similar, almost said the same, it's not. But we still start with autarky prices, at which case we have no exports. But at any higher price, we would see in the domestic Chinese market that the quantity supplied would be S1, the quantity demanded would be D1, and the difference then would be the exports that China has for tires. So we can bring our price measure over, figure out our exports, and that gives us a second point on our export supply curve. So remember, this is exactly the same as this. So again, filling in the missing spaces gives us our export supply curve for China. So now we've got import demand from the U.S., we've got export supply from China. One of the things that we know is equilibrium will be where the import demand is exactly equal to the export supply, right? What we're importing from China has to be equal to what China is exporting to us. So we could think about the autarky price in the U.S. and its import demand curve, and the autarky price in China, and its export supply curve. And of course, this then tells us the world quantity of tires that are being traded, and it also determines the world price for tires. And at this level, these are the Chinese exports equal U.S. imports. So we are in equilibrium where the import demand and export supply curves intersect. Now, let's put it all together. So